And our next geometry topic is one that you're probably very familiar with, or at least you've heard of before. This comes from your textbook section 5.8, so chapter 5, section 8, on something called the Pythagorean theorem. I think we might be familiar with Pythagorean theorem. You learn it a lot during your school years. For this particular section, you are permitted to use a calculator. You can use the simple TI-30, or if you purchased or have the bigger calculator, a TI-84 or a TI-83. On the final exam, you will be permitted to use the calculator from this section forward. Alright, so I'm going to try to use both to show you what it looks like, but either one does the same thing. Before we start, we need to learn how to label the parts of a triangle. So it's different parts of a right triangle. So Pythagorean theorem is specifically for a right triangle. It doesn't work for any other type of triangle. It's only for triangles that have that sharp right angle corner. So you'll notice all your examples have that sharp right angle corner. Alright, so there are two parts to a right triangle. You have your right angle, and across from your right angle, across the triangle, is what we call the hypotenuse, which you might have heard of before, hypotenuse of a right triangle. It is the longest side of the right triangle, and it's across from that corner angle. So if you find your corner, it's across, and that long side is called the hypotenuse of a right triangle. No matter which way the triangle's facing, if you find the corner and you go across, that is the hypotenuse of the triangle. So it's very important to find the hypotenuse first. The hypotenuse of a right triangle, and if you have a different color pen or pencil, it can help to emphasize where that hypotenuse is. The other two pieces of the triangle are the two short sides, the sides that come off the corner. And both of these have the same name. They're called legs. So this is a leg, this is a leg. One of them is usually called leg A, and the other one's called leg B. It doesn't matter which one's which. Leg A, leg B, makes no difference. But the other two sides that come from the right angle are called legs. This is a leg, that's a leg. Doesn't matter which one we call A or B, they're both called legs. So again, the other two sides off the corner are called legs. There's usually a shorter leg and a longer leg, but it doesn't matter. They're both called legs. Alright, so the formula for Pythagorean theorem, you might have heard of this before, a squared plus b squared equals c squared. So there's a, there's b, and there's c. A and b come from the legs. Doesn't matter, again, doesn't matter which one's which, they both come from the legs. And c is always the hypotenuse. So A and B can be switched around, but C is always the hypotenuse. So anytime you have a right triangle, you find the hypotenuse first, and then the other two sides are your legs, and they call it A, B, and C for short. So let's look at this quick demonstration. All three sides are already solved for. The purpose of the Pythagorean theorem is if one of your sides is missing. If you only have two sides, the Pythagorean theorem can help you find the length of the missing side. So if you're missing a side, you use Pythagorean theorem, and you can figure out that third side. Now on this particular triangle, all three sides are filled in. So I'm just going to demonstrate how this formula works. You find your right angle. Across from your right angle is your hypotenuse. So this 5 is what we call side C. Your other two sides are A and B, and it doesn't matter which one's which. A and B, and if you switch that, it's okay. So the way the Pythagorean theorem works, and again, this is just a demonstration, it's A squared. So if A is 3, 3 squared plus B is 4, 4 squared equals C, C is 5 squared. Let's just do the math and see if this works. 3 squared is 9, 4 squared is 16, 5 squared is 25. Is 9 plus 16 25? Yes, it is. So if you square the two shorter sides, square the short one, and add them together, you get the length of the longer one, again, squared. And Pythagoras was a Greek philosopher that figured this out. So he's a Greek mathematician that figured out this equation is always true if you have a right triangle. If you want to know more about how this formula came to be, you can read about it in your book. For us, all we care about is how to actually work it out. So I have a few examples. Most of you will be pretty good at this. We have calculators to help us out because some of these answers get a little messy. So I'll do the first few with you, and then you can jump in at any time, pause the video, and try it for yourself. So it says, find the length of the missing side, round to the nearest hundredth when necessary. So as soon as you see a right triangle with a missing side, you're going to find the hypotenuse. Here's the right angle, here's the hypotenuse. I'm just going to write HYP for short. So this is the hypotenuse. That means that this is side C, which means the other two sides are A and B. And again, it doesn't matter which one's which. And the formula stays the same at all times. A squared plus B squared equals C squared. So A is 5, 5 squared, plus B is 12, 12 squared, equals C is the one we don't know. So 5 squared plus 12 squared equals C squared. 5 squared is 25. And if you're not sure of that, you push 5. And then you should have a button that has a little x squared on it, and it will square it. On the bigger calculator, 5, and then again you have a button that says x squared, and then you hit enter, and it will square it. 112 squared is 144, which again you can find in the calculator, equals C squared. 25 plus 144 is 169, equals C squared. Now from here, this is something we haven't talked about yet. How do we undo a square? We don't want C squared, we just want C. So the opposite of squaring, let me write this down, the opposite of squaring is square rooting. So it's called a square root. So the opposite of squaring is square rooting. Now some of you might be familiar with this. On the smaller calculator, when you have 169, the button right next to x squared is the square root key. So the square root looks like a division house with an arm on it. So it has this little arm at the side. That is the symbol for square rooting. So if I push that button, it will square root 169. And so my answer is 13 centimeters. Now on a bigger calculator, it's different. On the bigger calculator, it's a little harder to find. You find the x squared key. Above the x squared key is the square root button. You see the little blue square root. In order to get to it, you have to push the blue second button, and notice your cursor changes to an up arrow. And then you hit the button, and it'll give you the square root. Sorry about the glare. So you have to hit second x squared to get to that square root button, and then 169, enter. And you get 13. So the bigger calculator, it's a little bit different to get to it. Alright, and you can practice that as we go, and if you get stuck, you can ask me during class. But the answer to the first example is 13 centimeters. Let's try the next one. Again, we're going to find the hypotenuse by finding the right angle and going across from the right angle. This is side C, which leaves the other two to be side A and side B. We're going to set up the formula the same. 17 squared plus 13 squared equals C squared. We don't know C. 17 squared is 289 plus 13 squared is 169. 289 plus 169 is 458. So 458 equals C squared. Now we're going to use that square root button again. So square root 458. What that does is it cancels out the squared and it gets you down to your answer. So on the big calculator, again, you hit second x squared to get to the square root, and then 458. On the small calculator, you hit 458 first and then the square root button. Now this one gives you a big ugly decimal, and that's okay. It told us to round to the nearest hundredth. So this would be 21.40. So this side is 21.40 feet. So sometimes you will get a decimal and you'll just have to round appropriately, which is why we have to use our calculators, because some of these square roots we wouldn't know. If you want to pause the video and try the next one, it works very similar. We're going to find the right angle and go across both this side to side C. So you always find that long side first. The other two sides are A and B, and it doesn't matter which one's which. And we plug into our formula. 5 squared plus 8 squared equals C squared. It's 25 plus 64. That's 89. And to undo the square, we square root. And the square root of 89 is not a pretty number. So you get a big ugly decimal. And we're going to round that off to 9.43. So this side is 9.43. It's being measured in meters. So you round to whatever place they tell you to round to. So Pythagorean theorem, this one gave you both legs and you had to find the hypotenuse. The next three give you the hypotenuse and one of the legs, and you find the other leg. So it's a little bit different to work through, but still, I think, very familiar. Same process, you find that right angle, you find the side across from it. This time we have side C. We have C. We're missing A or B, it doesn't matter. I'm going to call this A, and I'm going to say we're missing B. If you switch those letters, it's no big deal. So we still find the right angle, go across, and find the hypotenuse first. This one's going to work a little bit differently. We have 7 squared, because that's A or B, plus B squared, which is the side we don't have, equals 25 squared. 7 squared is 49, plus B squared. 25 squared, I always forget, I think it's 625, yeah. Now this time we're not going to add these two numbers together because we're missing this one. Instead, we're going to move this 49 over here. And remember, when we move things across the equal sign, we have to subtract. So we're going to subtract 49 from 625. That's going to give us 625 minus 49 is 576. Now we have B squared equals 576. And we're going to do the same thing we did above in square root. The square root of 576, ooh, it gives us a nice number, 24 yards. So side B is 24 yards. So this one was a little bit different. Instead of adding the two sides to the two legs together, we had to subtract from the hypotenuse squared minus one of the legs squared. So when you have the hypotenuse, you have to subtract. Same thing here. Here's our right angle. Across from that is our hypotenuse, so that is side C. And then the leg, you can call it A or B. I'm going to call this A. I'm going to say we're missing side B. And we plug into the formula. So again, the formula stays the same. A squared plus B squared equals C squared. 18 squared is 324 plus B squared. 20 squared is 400. Now because we don't have both legs, instead of adding, we're going to have to subtract here. So I'm going to subtract 324 from both sides. And you get B squared equals, I believe it's 76. And now we do the same thing, square root. The square root of 76 is a decimal. 8.7, that would round to 2. So remember your rounding rules. We have to look at the third place to round to the second place. So 8.72, and it's being measured in inches. So we're finding missing sides. If you feel confident, go ahead and try that last one. Here is your right angle and your hypotenuse. This is side C. So we're missing one of the legs, A and B. Again, it doesn't matter which way you label it. And we set up the same formula. This time I'm missing side A. A squared plus 10 squared equals 20 squared. 10 squared is 100. 20 squared is 400. And then again, because we're missing one of the legs, we subtract. A squared equals 300, and then square root. And the square root of 300 is 17.32, and it's being measured in millimeters. So that's your missing side, 17.32. So I think we're familiar with Pythagorean theorem. Like I said, in grade school, they really go over it a lot. If you're not familiar, it's a pretty simple process. You just have to plug into the same equation. You either add the two legs squared together in square root, or you subtract the hypotenuse squared minus one of the legs squared, and you still square root. So it's a pretty straightforward process, no tricks. The triangles will be rotated different ways, but if you find that corner and go across, that's always your hypotenuse. And that is section 5.8 on Pythagorean theorem.